All right. Good morning, everyone. Thanks for coming to the session. I know it's always rough on the last morning of the conference. We're going to talk today about, first off, can everybody hear me okay? Perfect. All right. So we're going to talk about Python today, but more specifically, we're going to talk about what you can do with it, to kind of help yourself as a sysadmin. So before we get started, I'll just tell you a little bit about myself. Longtime Mac user. I started, my dad's from the education field, so he's always had Macs around. I remember our first Mac was an Apple IIe, so it's kind of been a long time. But still using them, still love what they're doing. I'm a professional software developer now. I work for a company out of California called Pivotal. And we make lots of nice products in the cloud space and in the big data space. And I use Python quite a bit in my day job. Anything from web apps to just scripts to kind of automate things that I need done. Anything that can save me some time. So a little more detail about what we're going to talk about today. Just kind of. We're not going to do anything too basic, with Python. I'm going to kind of gear this as an introductory or as a intermediate level class. So we're not going to talk about the language really at all. I'm going to assume you guys have at least kind of a cursory knowledge of that. But we will talk a little bit about installing Python because it may not be quite what you think. Then we'll talk a little bit about kind of developing with Python, some tools that you can use, workflows, things like that to kind of be more productive. Then we want to talk about the standard library. The Python standard library is enormous, has lots and lots of stuff that's in there that can help you with your day job. And, sometimes people just miss things because there's so much there. So we'll talk about some of the cool libraries that you can use. And then we'll also talk about some third-party libraries because there's a lot of great stuff in the open source community that you can use as well. And then we'll kind of wrap things up with just a little quick bit about how you can package your code up. I'm sure you guys are all familiar with how to, distribute your apps across your Macs, but we'll talk a little bit about from the Python side of things on, what you can do to kind of package up your scripts and dependencies and things like that. So, introduction. Goals today. We're gonna, like I said, we're gonna dive into the world of Python development. I want to try to get you guys some. I hate this term, but best practices, I guess, into what you can do to write good Python code. Anybody can write Python code. It's not too hard to hack some stuff together, but writing good Python code makes a world of difference. So we'll talk about that. Show some of the tools that you can use. I'm not going to take a stance and say you should use this tool or not, but I'll give you some alternatives, things like that. You can kind of play with a couple different things and see what works best for you. And, of course, we'll talk a lot about why, Python's a great choice for, sysadministrators. There are other choices, Ruby, Boo, but, there's other things you could be using, so we'll kind of talk a little about why you should do it with Python. About the only thing that I'm going to kind of keep out of scope is just web development. You can do web development with Python. Works great for that, but just for the target audience today, we're going to avoid that. So installing Python. You might think that's easy. It comes on your Mac, so what more do you need to do, right? Well, the version that comes on your Mac is not always the newest. You might need a later version. There might be a bug or something you got to work around. You might want to try Python 3. That doesn't come on your Mac. So there are a few different things you can do to install Python. If you don't want the system version, you can go to python.org, and they have Mac versions you can download and install. It's pretty straightforward. And the other thing you can do is you can use what's called PyEnv, and PyEnv is a tool that will let you install multiple different versions of Python. It'll actually download the source code for you, compile it, and install it in your user directory, which is another nice thing about it. So you don't have to actually have administrator privileges to install it. And it keeps all the different environments separate. So you can have, 279, 2710, 3, whatever, all installed on the same system, and you can easily pick between which ones you want. You can set them globally, or you can pick which one you want per project. So it's a really handy tool when you've got different versions of Python that you're trying to mix and match. So developing with Python. Coding style. If you've done a little bit of work with Python, you may have kind of heard the term, idiomatic Python. What is that really? But just kind of, the Python style of coding. And, Python's pretty good, or at least pretty straightforward when it comes to style. There are actually, I guess, kind of standards for it. You've got what's called PEP 8, which is kind of like their, I guess, kind of like an RFC or something like that, but for specific to Python. And it basically just tells you, hey, these are the styles that, people should use when they, write their code. It'll make things easier for, someone else to pick your code up, see what's going on. You don't have to worry about, the variations in style. There's also this interesting thing called the Zen of Python, which, if we have time at the end, I'll pull it up and show you guys. But it's kind of a philosophy about, the way that you should write your Python code. And if you've never checked it out, it's worth reading through. It kind of reads like like an Eastern philosophy thing, and it just kind of gives you some thoughts about how you should structure things and organize stuff. And the other thing that's really nice is there are kind of linters, tools that will look at your code and say, hey, this isn't compatible with PEP 8. Your lines are too long, or you didn't indent this the way that is compatible with the style. So it's almost like a compiler, but it just gives you some little hints. So that's another thing I would strongly recommend checking out, because it will help you enforce that style, and not just have it as a guideline. And honestly, that sometimes is important, especially if you're working on a team. If you're managing a team, or if you're a senior developer and you want to make sure all your junior guys are keeping their code up to quality, you can have these linters run and make sure they're not checking in stuff that doesn't match with the guidelines. You can integrate the Flake 8 tool with your version control systems. Most of those have hooks and stuff that will run it at that time. I actually prefer to integrate with my text editor, and so whenever I save, it'll just pop up and say, oh, you did this, fix that. So I kind of like that better. It's quicker feedback, but you can do however you want. You can also just run it from the command line. So, kind of talking about tools a little bit, the main thing that you need an editor or an IDE. My preference is Vim. Not everybody likes Vim. I know there's a heated debate between Vim and Emacs, but I think in the Python world, Vim is kind of king. So there's a lot of nice tools for it. You can get cool things like syntax highlighting and the validation that I was talking about earlier. You can even get some basic code completion. You can do your control space to get like a little pop-up, and it'll tell you kind of what options you have there. Things you can press a button and it'll jump to like the documentation for whatever you're working with, stuff like that. I've some of my colleagues use Sublime Text, and it has a lot of the similar features. So if that's something that you prefer, it works great too. There are IDEs available as well. So if you want something that's like a little more full-featured, kind of you can go with that. PyCharm's great. PyDev is based on Eclipse, nice tool too. And then there's one called Ninja IDE, which I haven't used because I don't think they have a Mac version available, but I've heard it's nice. And I guess the only thing to say about it is there's no right choice. It's whatever works for you. I've seen teams where like everyone uses a different IDE, and it works because there's nothing that's necessarily specific about it in your code. Just whatever tool you like. So once you get your IDE situation kind of taken care of, the next thing that you have to think about is kind of dependency management. And if you're not using any third-party libraries, this is easy. You don't have to do anything. Everything's in the standard library, so you don't have to worry about it. But if you start to use third-party code and you're pulling in dependencies, you then have this issue of, they have to install on your system. And what if you have two projects that use two different versions of something? They may not necessarily be compatible. If you've got a Python 3 project and it's using something and a Python 2 project and it's using that, you could have some collisions. So Python has this thing called a virtual environment. And essentially what it does is it's kind of like a separate collection of libraries that you can install. And there's two tools that are really nice for doing that. One of them is called virtual env, and the other is virtual env wrapper. And they both work about the same. You run the command and it'll create a separate space for all your third-party libraries. And you can just install whatever you want. Again, one of the cool things about this is that you don't need root access to do that because you can create the virtual environment in your own workspace. So then you can install whatever you want in that workspace. You don't have to, if you don't have admin access to your PC for whatever reason, you don't necessarily, it doesn't matter. I have a link here. You can take a look at the slides later if you want. It just kind of has some quick tutorials on these two, so if you want to see, how to use them, kind of how to get started with it. It's all pretty easy. You install it, a couple commands you can run, and it'll create the environments for you. The tool I mentioned earlier, PyEnv, also has plugins for both of these, so it kind of makes it easy to work with PyEnv and these tools together. So that's something that's nice. I don't necessarily think either tool's better. They both work great. I've always used virtual env because it was just the first one I picked up, and it's always worked for me. But a lot of people use both. I would say just pick one and use it. It's not something to get caught up on. They both do their job well. Testing tools. All right. So a lot of what we're going to talk about today is writing good code, and to write good code you need tests, because you need to guarantee that your code is doing what you think it's doing. Python is not a compiled language, so there's no compiler to check your code to say, hey, you didn't do this right. So the only way to do that is to run the code. And so a lot of times with more complicated scripts and libraries, you can't just run the code and test everything. So you create what are called unit tests, and they just test little functions of your code. And so to run those tests, you need some sort of tool, that goes through and just says, here's what happened when I ran those. This one broke, this one didn't. And there's a few tools in Python that do that. There's a unit test library in the standard framework that you can use, and it's a little basic, but it works good. Some of the other testing frameworks are kind of based on it, so you'll see it even if you use other stuff too. But to run your tests, you just Python-m unit test and then the name of the test, and it'll just go through and run everything for you. There's other test runners, is what they call them. You can Google for them as well. I usually use the ones called nose tests, and they just tend to be maybe a little more convenient when it comes to running the test. They'll do some things automatically for you, like recurse through a directory and find all the tests in that directory. Run them all at once. So just they have some nice options for things like that. Again, it doesn't really matter which one you use. They all kind of do the same thing. You might see some stuff online about this one's better or this one's better, but at the end of the day, if it runs your tests and you get the output that you need, the feedback that you need, it doesn't really matter. You just pick the one that you like, pick the one that works for you, and kind of move on to more important things. Again, you can also integrate your test runners with your IDE or with your version control. I like this tool that I linked to here. It's called tdaemon, and what it does is it will it will just sit and watch your directory. And whenever a file changes, it'll run the tests automatically for you. And I'll show that later, but it's kind of nice because then you don't have to control, tab back and forth, between windows and run the command. You can just kind of, keep it open on the side, and you can see when stuff breaks and when stuff works. So when you start a new project, there's a couple ways that you can do it. A lot of people will just start, with a single file and kind of go from there. There's nothing wrong with that. If you're writing something that's, small or simple, can work quite well. You can just kind of knock it out and get it done. But once you start to get to something that's a little more complicated, you need to have a little bit of structure. And there's no, I guess there's no right or wrong way to structure your stuff, but this kind of suggestion that I have here is a very common thing that you'll see, when you're looking at, open source projects and third-party, projects that you can get. And essentially what you'll have is kind of this grouping of directories here. And so you'll have a directory with whatever your, project's called. And then that's going to contain all the source files. Oftentimes inside that directory you'll have another folder, that's called the module name. You may not, you may have other, you could have, a handful of files in here. But that's going to be basically the source code for your project. You can optionally have a bin directory, which would be things like scripts. You might have like a quick shell script that launches, the program for you, sets up the options you need, something like that. Docs, that's self-explanatory. You get this magic setup.py file, which we'll talk about at the end. It's what Python uses to help you package and install stuff. But that's something that, if you're going to share your code with other people, allow them to easily install it, you should have this in your project. Tests, again, that's pretty straightforward. You put all your tests in here. These will be tests corresponding to your to your source code. Exactly how you structure that doesn't really matter. You can put a handful of files there. You can put a bunch of stuff in one file. Whatever you're comfortable with. And then scripts is kind of similar to bin, but you can put utility scripts. If you've got some software you're installing and there's like a cleanup routine that you might need to run every once a week or something, you could put that script in here, and then in your in the setup.py file, you can tell Python, hey, these are some extra scripts I have. Install these for the user. It'll give them some more functionality, and it will install that for you. And then obviously you need a README, so people know.
Try again.
Hello? Oh, there we go. That's better. All right. Some other odds and ends to consider, when you're doing your development. You're definitely going to want source control. It doesn't matter what you use. I like Git. It's nice, but there's other stuff too. Mercurial works really good. Some people still like Subversion. So whatever your team's using, whatever your group likes, go ahead and use it. You just want something. Source control is vital. You need a good terminal. A lot of this stuff you're going to run on the command line, so you want something. I don't prefer the built-in Mac terminal. I like iTerm. I just feel like it's got a little more flexibility. It does what I want it to do a little better. Some people will install additional interactive shells for Python. By default, if you just run Python with no arguments, you'll get a command line, kind of like a Python interpreter that you can just type commands in and do stuff. And it's real nice for checking stuff out. If you want to, write a quick little test, see how something works, you can do it in there. But there's also kind of enhanced versions of that. There's one called IPython and BPython, And they offer more functionality, give you, the ability to do different things. So, you can check those out if the default one's not really meeting your needs. And then the last thing here is called, I think it's pronounced Sphinx. And it's kind of like a doc generator. So when you write your Python code, you can inline, if you follow the PyDoc standards, you can inline comments and information about the code. And what Sphinx will do is it'll go through your code, pull out those comments, and generate automatic documentation for you. And so it's a very handy tool to have, especially if you're writing a library or something that another team or another group's going to consume. You can document it for them so they know how to use it. So enough boring slides. I'm going to show you some demo stuff here. So that project structure that we talked about, there really isn't a way with Python to say, hey, give me one of these projects. I want something. You can create it by hand. They're not that complicated. I kind of put together a quick shell script that just does it for me. I'll show you guys that here. If you're creating a lot of new projects, it might be something to consider. You can share it across your team, just to help people get started real quick. But it's just a little shell script, and it goes through, creates the project structure that you want, sets up a Git repository, adds my code to it. I'm using PyEnv here, so I'll tell it what version of Python that I want. I'll create a virtual environment for me, install some packages. Like I said, I use Nose for testing, and add my dependencies and stuff. And then once the script's done, then you've got a nice environment that's ready to go. So if I want to run this here, you can see it's just going through. It created all my directories, and it's installing those test tools that I asked for. And these, you'll see these two files occasionally when you're looking at third-party code, requirements.txt and requirements-dev.txt. And basically what those are is, it's something that you would check into source code and says, hey, if you want to run my project, here's the dependencies that you need. And the tool to install the dependencies is called pip. And pip can take those text files and it will just automatically install everything for you. So typically the workflow is that you've installed all your third-party libraries that you need. You generate this file and then check it into your source control. And then when someone new needs to install the project, they clone your repo and just run pip and feed it in this file. And then it will just install everything they need. Then they have the exact versions that match what you had. So it's just kind of a convention for making it easy to share your code. So here's my demo project. You can see all the stuff that it created for me. I've got my module directory. I just called my project demo, so it named that directory demo for me. If we look inside that, it created this little structure for me. You've got this kind of weird looking file here. This is just kind of Python magic that it takes the directory and says, hey, this is actually a Python module. So instead of being just any other directory, the Python will see that and kind of know this is something that I can import and use in Python. It's actually, if you're wondering, it's actually an empty file. Oops. Nothing in it. Doesn't have to be anything in it. You can actually put code in there if you want. If you need to do something when your module's loaded, you can add it in there. But by and large, it can just be empty. Just the presence of it is enough for Python. This is the requirements file I was talking about. It gives you just a list of what's installed. You can run pip-r and give it that file, and it will just install that stuff for you, which is very handy. All right, I'm going to switch back to the slides, but before I do that, just take a quick second, see if anyone has any questions. Covering a lot of ground here real fast, so I don't want to pass anything by. Questions? All right. So we'll kind of move on and talk about development workflow a little bit. The workflow that you typically would see someone starting out with Python using would be, create a file, write a little bit of code, run that file and see if it works. If it doesn't, then go back to the drawing board, write some more code, run it again, kind of repeat, until it works. It's okay. There's nothing wrong with doing that. If you're writing some smaller scripts or, some prototypes or code that you're just going to use once and kind of get rid of, there's nothing wrong with it. But it does have some drawbacks. In particular, if you're creating something that's going to be a bit larger of a project, or a project that you're going to try to share, or something that's going to have a long lifetime. The trouble with it is that, as your code gets more complex and as time goes on, you're going to forget what some of that code does. And then if you need to go back and change that later, it makes it really hard, because you don't have anything to tell you, when it's working properly, or if that change you just made broke something. There could be some edge case that you coded in last time and you forgot about, and now you've broken that. So, regressions can happen. And so to kind of combat that, my preference is to use what's called a test-driven workflow. Some people, I think there's a formal, test-driven development kind of style. I don't do anything that's that, official or that formal, but, I think tests are very important. And so that, it's kind of the center of my workflow. Usually what I'll do is I'll try to write a test first. That way I can think about, what I want to do, what that code should look like, how I want the method to work, or how I want the class to function. And then I will go ahead and then write the test behind that to make it work. And the nice thing about writing tests to do that, you get you're really fast, iteration on what you're doing. You can, when you have that little test that just stresses one little piece of your code, you can, really quickly, iterate on that and find what works, fix bugs, and get that working to the point where then you can move on to something else, and then you can just forget about that chunk of code because it works and you have a test to prove it. So that's kind of roughly the general workflow that I'll go through, and I'll show that a little bit here in a bit. I want to do some live coding so that you guys can kind of see some of this stuff in action. And then also what this really does ultimately is, a year from now when you have to go back and make some changes to the code to add something new, you know that your code still works after you made those changes. It gives you a lot of confidence in what you're doing. It can make that maintenance time, go down dramatically. If you don't have to retest, everything manually by hand, or run a bunch of commands, or pass it off to a QA team that's, going to sit on it for 2 weeks. It just makes your life a lot easier. It's not perfect. There are some things that can be a little troublesome with it. You're going to write more code. There's no doubts about it. You've got to write these tests. That's additional code you've got to write. It's additional code that you have to maintain. But the benefits of what you're getting are generally worth that extra effort. And some things, as you'll see, I think in the live coding session, some things are just not easy to test. It's easy to test a prime number generator or something that's has defined inputs and outputs and expectations. But if you're testing a function that draws a graph for you, it's kind of hard to say, well, are those pixels in the right spot? So it's not always easy to test everything, but if you can test the core, you can test the majority of your stuff, it will help you out a lot. So, like I said, I'm going to do a little bit of live coding. Hopefully things will work out here, and we'll have a nice demo for you. I've got some notes at the bottom there. You can just feel free to ignore those. So first thing we're going to do to help with our testing, we're going to install this additional tool. It's called Dingus, and it's a mocking tool. And it'll help us with some of the cases that are difficult to test. So a perfect example of that is the file system. If I have something that writes to the disk, you could in a test, you could write to the disk, and then and read back what you wrote and check it and see if that's what you expect. But that can get kind of complicated, and it can be a little bit of a pain. So what you can do is you can use a mocking framework, which will kind of inject a dummy, I guess for lack of a better way to say it, like a dummy implementation in place of what would normally happen. So instead of writing to the file system, you're going to just call this mock, and the mock's going to say, hey, someone called me, this is what they gave me for the arguments, and this is what I gave them for the return value. And so you can kind of cheat a little bit, I guess, and make your tests a little bit easier to run. So first thing I'm going to do is install that with pip. Oh, crap. Actually, the first thing I'm going to do is fire up my virtual environment. So I ran this, I basically just sourced this file here, which is in my virtual environment, which is this env directory. And that just activates the virtual environment. It messes around with the shell environment a little bit, and you'll see this little tag here at the beginning of my prompt that tells me that I'm in the virtual environment. When I'm done with that, I can run deactivate, and it will roll those changes back. So I'm going to install that tool. And we'll go ahead and open our files here. And is that big enough in the back?
It's very hard to read.
Still hard to read?
It's just because of the colors, though.
Oh, okay, the color here. Interesting. All right, let me try something here. Is that better? Okay. All right, so kind of what I'll typically do when I'm writing some code. I'll have two windows open. On the top here, I've got my test. On the bottom, I've got my demo. Makes it easy just to kind of flip back and forth, see what you're doing, reference your code. And then, as I mentioned, we've got this nice utility called tdaemon. And what that'll do is it will just run, and it'll check these directories that we have, and when stuff changes, it'll rerun our test for us. So I'm going to start that up here so you guys can kind of see what's going on in the background. And so it just tells us it's ready and waiting. All right, so as I promised, the first thing we're going to do is write a test. And so you don't have to watch me type. I'm just going to copy and paste that here. And what we got at the top, we're just importing our mock framework. And then we're importing a kind of a helper method that will, it'll check our, check stuff for us, compare values, stuff like that, and then give us a nice output when they don't match. As far as writing your tests go, it's pretty simple. You just create a class. It doesn't have to extend anything. It just, just itself. And then you just add methods. And the test runners, what they do is they look for classes that have certain name structures. So, I believe it looks for things that start with test. It looks for methods that start with test underscore. And as long as you kind of stick to that pattern, it'll find your tests and it'll just automatically run them. So the code that I'm going to kind of try to put together here is just a little utility that will run vmstat, which will dump some memory information from my machine. It's going to kind of parse that, and then it's going to save it to a file. And then if we have time at the end, we'll add a complementary script that will read the data that we've saved, and it'll generate a graph for us. So we can see a nice kind of pretty graph of the memory usage on my machine. So first thing that we're going to do, we want to run vmstat to grab that information. So we're going to write a test function that is going to test that we're running vmstat and getting some output. So if you look here, I'm using this mock object that I talked about. And what this is doing is it's looking at the subprocess module, which in Python is a library that lets us run additional shell commands. So vmstat's a shell command, so that's what we're going to use. And then check output is a kind of a helper method that will just say, hey, here's my command, here's the arguments, run it and give me the output. So what we're doing, this will be the code that we're going to implement here in a second. And we're going to get the value and then make sure that it matches. One second here. I have this backwards. So I had to change the name on that. The test runner wasn't finding it because it doesn't match what it's normally looking for. Perfect. So we can see our test runners running now, and it's telling us, hey, I don't know what this is. I can't find it. And of course, it's doing that because we didn't write it yet. So the next step is to write that code. And I'm not necessarily going to write all of it. I'm just going to kind of start with a nice basic thing that will try to satisfy our test case here. So I'm going to add in this code. And what this is doing is it's including the subprocess module, and it's defining our run vmstat method. And so at this point, we should see that it's able to import it. But if we look back, we can see it's still not. And the reason that it's not is it has to do with that magic init file that I was talking about earlier. And when Python imports our module, if we look at the directory, we've got this demo folder. And so we're going to be importing demo. And then we've also got a sub-project. So in actuality, if we wanted to import this, it would be demo.demo. Whatever. And since that's kind of ugly, we want to put in our init file, let me open that here. We're going to kind of cheat a little bit and just say from demo import star. And what that will do, is it will import everything from the demo sub-project or sub path and include it into the main one so that we can just say, from demo import blah blah blah. So it's just kind of a little cheater thing. Let me start up the test runner again. All right, so we got progress. Now what it's telling us is, hey, these things don't match. And if we look at the code, we've got essentially we're calling subprocess, we're calling check output, and then that's going to run vmstat for us. And we've got our mock running here, and it looks like it's not returning a value, and that's okay. But we just need to instruct the mock on what to return. Since this is kind of a dummy implementation, the default is just to return itself. And so when we look at this output here, we see, this is the mock object, and of course that doesn't equal the string that we're expecting. So we're just going to add a little bit of code to tell it what to return. And we'll just put that right there. All right, and if we look back, lo and behold, our test passed. Yay! So that's kind of the basic workflow that that you're looking at. When you're developing this stuff, you write the test, you make it work. Once the test works, then you move on to the next thing. And I've got a whole bunch more stuff we can kind of walk through and add some more functionality here. I'm going to switch back to the slides at this point, though, just to make sure we touch on some of the standard library stuff here. We're doing good on time, but I want to make sure we talk about that. And then we can do some more live coding. All right, so the standard library. In my opinion, the standard library is one of Python's nicest features. It has so much functionality included out of the box. A lot of times you'll hear Python termed as batteries included. Because there's just so much there for you to do. And it's great. Why would you want that as a sysadmin? Well, because it's just less stuff you have to install to make your scripts work. Instead of having to install some third-party libraries or whatever, you can just pass someone, a text file, say, hey, run this, and here you go. That's everything you need. You don't have to install anything else. So it makes your life a lot easier. A lot of the libraries are just written in Python, so if you ever wonder what one of them is doing, you can generally crack it open and take a look. It's sometimes helpful, if you find a method that's doing 90% of what you want, and you want to do something slightly different. You can pull the code into your own code base and just make a few edits, and you're off to the races. The other thing that the standard library does that's really nice is it gives you an OS kind of abstraction. Everyone here is probably running on a Mac. That's our conference, but not the whole world does that. And the fact that you can write a Python script, have someone run it on a Windows box or a Linux box, and it's just going to work because the standard library handles all that cross-platform stuff for you. So another thing that just makes your life a lot easier. There's lots and lots of documentation for the standard library. I would say that I very rarely spend time looking at the Python documentation, and I always spend time looking at the standard library documentation. It's kind of the place to go if you want to understand how a library works or what functionality that the standard library has to help you accomplish a certain task. And the docs are there are very good. They have lots of information. Code examples, things like that. So it's an excellent reference. I have kind of broken this down into different sets of libraries, and the way I've kind of grouped them is in terms of what I think is going to be the importance for a sysadministrator. these are going to be these fundamental libraries are the ones that you're probably going to use in almost all your scripts. Regular expressions. I'm going to guess that most of the people in this room have written a regular expression at some point. Python has a nice support for regular expressions, so you can use those, integrate them into your code, use them for parsing things and matching and all that great stuff. And we'll see this in a little bit in the live coding because we're going to use that library. Date, calendar, and time are your basic date and time libraries that Python supports. Gives you the ability to do things like get the current day, do some basic date math, get like time. You can get like a time stamp of what do they call that from the epic. If you just need like the count of time in seconds. Calendar gives you some functionality that's a little higher level, but doesn't quite fit into the other two libraries. So those are all things that you'd use. A lot of times I'll use those if like, say I want to create a text file and I want the date to be embedded in the text file name. You can use datetime to grab the current date and then format it however you want. Random, pretty self-explanatory. You need some random numbers. That's the library to go to, but it also has some cool functionality that's layered on top of that. You can pass it a list of items and there's a method that'll shuffle them for you. Things like that are just little nice helpers. This next one's kind of not well known, but I really like it. It's the itertools library, and it gives you a lot of fast and efficient ways to iterate on collections. And so typically when you iterate on a collection in Python, it's great for smaller things, for smaller collections. It's going to run really fast, but if you have an enormous list or an enormous data set that you're trying to go over, the way that Python does that behind the scenes isn't the most efficient. These methods here have a different kind of back-end implementation that makes iterating across those lists a lot more efficient. So, if you want to filter a list that has, 1 million objects in it, this is a lot better to use than the corresponding function, built-in function without the leading I. So that there are built-ins that are just called filter, map, and zip. The I filter, IMAP, and IZIP functionality is just kind of this enhanced implementation for when you're using with large collections. The sys library is, it's not one that you're going to use a ton, but there's really two things that you're going to use it for. Getting the command line arguments that were passed to your script, and then exiting, if there's a problem. There's other stuff in there. You can set the Python path and some other things, but generally those are the two things you'll use the sys module for. OS is something that you'll probably use all the time. It gives you access to environment variables, user group info, and the big one, which is the file system. This is where you can do things like walk a directory tree and delete files, and I think it's got copy and move files and things like that in there as well. So that's one that you'll constantly use. Along the lines of those file APIs, there are a couple other nice libraries that will help you, when you're writing tools that work with the file system. From the OS library that we talked about, there's a method called walk, and what that will do is you give it, whatever directory you want at the root, and it's going to recurse, and it's going to go through every file in that subdirectory. So, I think you can probably see where you can go with that, but it's great if you want to. Look through that directory for things, remove certain files, or process a set of files. You've also got basics in there, like making a directory, getting information about your file with like the stat command, and things like that. The companion to OS is os.path, and to access anything in the file system, you need to put a path together. and os.path gives you utilities for manipulating that. You can join things together to create a path. You can, there's kind of a complement to the, it's like the shell command dir name and base name that you can use to strip off the end of a directory or strip off the file name. There's methods for like pulling off the extension, things like that. And you might be thinking like, well, it's not too hard to just implement that stuff myself. But the nice thing about using os.path is that it's gonna handle that appropriately across platform. And if you're just writing stuff for your Mac, it's not the biggest deal. You probably can handle that yourself. But if you're trying to write something that's going to run on a Windows box as well, you really want to use os.path because it will handle all those weird things that Windows does, like backslashes in the path name and direct all that stuff. So it's just a good habit to use os.path. Temp file, as you'd expect, gives you temporary files and directories. And that can be really handy, if you just need a quick place to stash some code, some data, that you're processing. And the nice thing about temp file, again, it's probably something that you could implement yourself, but temp file handles it correctly. It handles it so that they call what they call securely, so that you don't have problems with like race conditions where someone could use your temp directory to exploit what your code's doing. So again, it's just good practice to use temp file if you need somewhere to stash stuff. There's a fairly, you don't see it used a whole lot, but it's pretty handy library called glob. And basically what it does is it just gives you some the typical Unix style pattern matching that you'd see, like in Bash. And you can say, give me all the files in this directory, that match this pattern star.gif or whatever. So it's just kind of a nice helper for writing your scripts there. And then shutil is it's kind of a higher level of abstraction than the OS module. It does some of the same stuff, like you can copy and move files, but it gives you some additional stuff like copy a whole directory. And so instead of having to os.walk through a whole directory and copy all those files, you can just run copy tree and it will copy everything for you. Same thing with remove tree. If you want to delete a whole folder of stuff, a lot of times I'll use this in my unit tests. If I am going to write some data, temporary data or something in a unit test, you can use copy tree to seed that temp data. Use remove tree to clean it up when the test is over. So, another thing that you're probably going to have to do as a sysadmin is parse stuff. From a basic standpoint, you need to parse arguments that are passed to your script. That can get complicated depending on, what you want your script to do. If you got a lot of options, let me step back. If you only have a few options, you can kind of handle that yourself. You can just read the sys.argv list. You can, do some basic logic and, enforce that, your users are passing in what they should be. But when you get to more complicated setups where you have lots of arguments and optional arguments and arguments that, take values and some don't, some are just flags, you kind of need a library to help you with that. And Python has a couple. The recommended one to use right now is argparse, and I believe that's in 2.7 and 3. So if you're using a slightly older version of Python, you might not have that available. There are a couple other ones. There's optparse and getopt. Those have kind of been deprecated. Argparse is just the preferred way to go. It's got a nicer API, nicer implementation. And then you kind of have all your various different, file formats and things that Python can read. It can handle JSON and XML really well. It can handle CSV files. We'll see that later. I'm going to try to use that in our some of the live coding I'm going to do. there's a codex library that will handle text encoding for you. So you can do things like convert between ASCII and Unicode and all that fun stuff. And then it's got some object serialization support. Python calls it pickle, but basically if you have a class in Python and you just it's got a bunch of state and you want to save that, so the next time you run you can quickly load it. You can just pickle that and save it to a file, and then when you start your app the next time, you can just unpickle it, and you'll have that same exact set of data back. There's a lot of other stuff in the standard library too. You can kind of peruse through the docs and see some of these. There's a whole host of libraries that you can use to parse email. You can do things like convert from mbox format, to some other format, or scan through your emails for certain things that you might want to remove or delete. So a lot of things that just as a system administrator, you might have to do it at one point or another. So as you're writing your code, invariably something's going to go wrong, and it's going to be hard to tell what. You may not have a clue. When your code breaks, you'll get a stack trace, so it'll tell you roughly where that code failed, but you don't have a lot of state about what was going on at the time. So you don't necessarily know how you arrived at that point. What caused that to happen. When you're trying to debug that, there's a couple ways you can go about it. You've always got the kind of the old standby, which is just print. As your code's running, inject some print statements, print out what you want to see, and then you can kind of view that state as the application's running. Not the best option, but it's actually one that I find myself going to fairly frequently. If you're working with unit tests and small blocks of code, adding a print can usually tell you what you need, and it's pretty quick. There's also a pprint or pretty print module that Python has, which will kind of make printing collections in larger objects nicer. It'll format it for you so that you don't have like just a terrible long line of stuff that you're trying to look through. So that can be handy as well. If you need to step it up a little bit and kind of actually walk through your code and see what's going on, you've got the Python standard debugger, which is PDB, and that comes with all Python versions. So you just basically run your code and you set a breakpoint, and then PDB will fire up when it hits that breakpoint, and then you can go from there. If you've ever used like GDB to debug code, it's very similar to that. You just kind of have a command line interface, and you can step through code, you can print values and all that good stuff. There's a nice enhanced visual version of that called PUDB, and it's still a console program, but it kind of has like a ncurses like console GUI to it, and it's really pretty slick. Takes a little bit longer to fire up, but it can be really helpful if you've got a big code base, or especially if you're not familiar with the code base. Can be kind of helpful to walk through, and it gives you kind of a nicer view of things. When it comes to performance, you can profile your code. The kind of standby there is just time it. Python has this time it module where you can actually just run it from the command line and you give it a string of Python to run, and it'll basically run it like a bunch of times and then give you the stats. Here's how long it took to run it, and then so you can kind of tweak things and see. It's nice for like if you're trying to optimize an algorithm or something like that, where you want it to run absolutely as fast as possible. You can keep doing that. There's also some stuff that you can import into your code from the timeit module to kind of like capture the times for certain sections of code and things like that. And then kind of step up from that is there's profile and C profile libraries, which allow you to do a lot more in-depth stuff. I believe they can kind of give you like a line-by-line breakdown of the performance of your code, and so you can kind of see where things are breaking down. And that's kind of a little more helpful if you're not sure what's breaking down. If you know what part of the code is making it slow, Time.It's great because you can use it to optimize stuff. If you're kind of trying to figure out where your code is slow, Profile is kind of the way to go. And it's fairly straightforward. The documentation for the standard library has some nice info about that, so you can kind of check that out. The C profile library is the same thing. It's just written in C instead of Python, and so it tends to perform a little bit better if you've got like a really big code base or something like that. You'd probably want to use C profile because it'll run a little more efficiently. So some other useful APIs that you're going to want to probably run across at some point. You've got your compression libraries, so you can zip stuff up, unzip stuff in pretty much any format you can imagine. You've got some basic crypto libraries. Hashlib is one that I use quite a bit, which lets you get things like MD5 hashes or SHA-SUM hashes of things. There's a HMAC that gives you some more cryptographically secure hashing and stuff like that. I don't tend to use that one as much. There's Python has a logging framework built in. My background is kind of started more in the Java realm, and there's like 37 different logging frameworks, and everyone has their opinion about which one's best. It's refreshing coming to Python and seeing kind of one logging framework, and that's what everybody uses. So, it's great for adding logging to your code. Kind of the difference between this and just printing stuff out is that with the logging modules, you can turn stuff on and off. So when you log something, you give it a log level. You can say like, this is something that only I need to see when I'm trying to debug something, so I'll put this at the debug level. Or this is generally good information. Users should see this when the app's running. And so then when you run your code, you can change that level appropriately based on what you're trying to do, and that will adjust the verbosity of what you're seeing. And so that can be kind of a step up from just printing stuff to standard out. Subprocess, I touched on this earlier, is a way to spawn additional processes from your code. It's got a couple nice helper methods. There's I think it's like there's one that will basically just call your code and return, and if the code ran correctly, so if the exit code was 0, then it will return true. If it returns a bad exit code, then it's going to generate an error. There's the one that I was using, which will basically run the code, grab everything that was written to standard out, and return it to you as a string. And those can be kind of just handy ways to quickly run something. You've got a signals library, which you can use if you're trying to trap signals. If you want to do something, when the program is about to terminate, you can set up a signal to catch that. There's a socket library if you're going to do any sort of network I/O. It's pretty low level, so a lot of times you're probably going to want something that's built a little higher up the chain. If you need a web server, if you need something like that, there's probably other libraries to use, but it's there if you need to get kind of down and dirty. And then you've got some libraries for sending HTTP requests. It's kind of basic HTTP client support. This is one area where the standard library doesn't really have the best functionality for you. It'll get you the basics. If you just need to send a GET request or post a small amount of data, it's going to do fine. But one of the areas where there are kind of a lot of third-party libraries that are really nice is in this space. So I kind of draw the line where if I'm doing something simple, I'll use the standard library stuff just so I don't have to have that third-party dependency. But anything that's mildly complex, I'll pull in a third-party library because it just makes my life easier. And speaking of that, we'll talk a little bit about some third-party libraries here. These are broken down. There's really two types of them. There's ones that improve on existing functionality, and there's ones that add additional functionality. And so I've got some here that are just general improvements. The first one is called requests, It's just a much nicer library for sending HTTP requests. A lot simpler to use, very popular. I think it's one of the most popular Python projects out there. There's one called wrapped, which is a nice way to create decorators, if you're familiar with that concept in Python. There's PyTZ, which is essential if you're doing anything with time zone conversion and stuff like that. It will make your life a lot easier. There's one with the best name. It's called DeLorean, and it's a date time library that gives you kind of a higher level, nicer API than what's in Python. There's PyCrypto, which has a lot more cryptographic functionality. SH, which is like it's a library for doing basically shelling out to stuff, but the way that it's set up, it's got a nicer API than subprocess. And then there's docop and click, which are other command line processing libraries. So they just kind of have, again, different APIs that might be a little nicer than the built-in argparse stuff. So new functionality, there's a couple here that you might want to check out. There's, I spelled this wrong. It's Paramiko, and it gives you SSH or SFTP. So you can automate things. If you want to connect to a remote server and download some files, you can do that in your Python code, or connect and run some commands on that remote server. You can do that. PyYAML is a YAML library that's kind of a new format that's gaining a lot of traction. Matplotlib and PyGal are nice graphing libraries. If you want to generate some pretty graphs, you can do that with these. And ReportLib is awesome for PDF generation. If you're trying to generate some reports that you're going to ship to your boss or some higher ups, ReportLab can automate that. So it's kind of nice. I've also got a link here, which you can check out later in the slides, it takes you to a site that has a list of like the top, 300 or 400 popular Python libraries. So you can just see what other people are using and kind of check out what those do. All right, running a little short on time. So I think instead of doing a little bit of the live coding, I'm going to show you the stuff that I worked up already. So this is the demo project that I was talking about, and it's got two bits of functionality. One of them will run vmstat, and it will grab memory output, and then one of them is going to take that information that we saved, and it's going to generate a pretty graph for us. And let me open these up so I can just show you guys some of the code. And kind of the idea about this is not to just show off this code, because it's not the world's greatest code, but it's just more to show what you can do with the process and how you can generate some nice clean code, to write your projects. Let's see here. I'll make those bigger in a second here. Is that visible in the back? Awesome. So we can see that I've got my test set up, and I pretty much have one test corresponding to each function that I created in my program. So I've got this one that we coded up before, my function there, and then this is the identical. One of the other things, this is an example of parsing some information, and the way that I have the test set up, it's going to take the information from vmstat, which just gives you a bunch of text, and it's going to try to make sense out of that. And the output from vmstat's nice, it's formatted well. You've kind of got like label, colon, and then a value. So it's fairly easy to pick apart. And so what we've done in the test is we just set up the test to run the parse command, and then we're just going to look at the output. And we want to make sure that we've got the right number of lines, and then we check a couple of the values to make sure that they match up. What you can see I'm doing here at the top, and this is key for your test, because every time you run vmstat, it's going to give you a different output. So if I were to actually run vmstat in my output, I'd have no idea what to expect. So with your tests, a lot of times what you'll have to do is capture some consistent data and save that. And so a lot of times what I'll do is in my test directory, I'll have like a data subdirectory or something where I kind of stash that information. And then the first thing the test will do is read it. So in this case, you can see I ran vmstat and just piped it to a file. And I'm just reading that back in so that when I run the test, every time it's going to be consistent and I know exactly what to expect. And then over here, you can see an example of using the regular expression library. So we've got our, not too nasty looking regular expression here. And, the process for using that is basically you compile the regular expression and then run it. So in this case, you can see right here, we're taking our compiled pattern and we're saying, does it match this line? And if it matches that line, then, we've set it up to pick out certain parts of that line. And so we're picking out the tag, which tells us what that information is, and then we're picking out the value, and we're essentially just setting that into a dictionary. So when this runs, we're going to have a list of keys, which is going to be the information, and then that's going to correspond to a value. Then the last thing that we want to do in to complete kind of our first operation here is to save that. So every you probably run this command and have it loop. It's going to run in the background, something like that. And every, second, 5 seconds, however often you want to grab that data, it'll grab it, parse the information, and then it's going to append it to a file. And so to store that information, we're going to store it as CSV. It's just common to limited text. Python supports it well, so it's very easy. Again, we're loading our test data so that we have consistent information. And then we're kind of doing a little bit of a trick here. And this is something that you'll probably do a lot in unit tests when you're writing to a file, is instead of writing to a file, Python has this cool thing called a string IO object. And it implements, it does the exact same thing that writing to a file does, but it just writes to memory. So it's awesome for unit tests because then you can write to memory and you don't actually have to involve the disk or create temp files or folders or anything like that. And so what we do is we just patch that in and say, when my code calls the open method to open a file, I'm just going to return this mock object, which is going to return the string IO object instead. So when my code writes or when my code runs, it won't know what's going on behind the scenes, but we've tricked it into using this other implementation. And then once that runs, all we do is say, give me the value, gives you the value, and then you can test on it. And so, we're just kind of doing the same thing. We're checking a couple parts of that CSV file to make sure it's written the information the way we expect. And then in the code, you can see how simple it is, to work with CSV files. All we're doing is, we're opening the file, we're creating a dictionary writer, which understands, that we have a dictionary, and we're giving it the list of keys to write. And so we're sorting them so it's a consistent order, the keys, and then it's just going to append that information to the file. So every time it runs, we'll just get a new line in that file. And I'll go ahead and run that so you can kind of see what it looks like. And so, I've kind of just added some basic usage info there, just kind of a nice thing to do in all your scripts so that, if someone runs it, they can kind of figure out how it works. And we'll just run collect. Okay, well, the demo gods aren't smiling on me today. I wish that would have worked, but I think I have, nope. All right, well, I'm running short on time, so I won't be able to fix that. But if you're curious to see how it works, I can stick around after and show you guys. The other kind of flip side of this is we want to pull that information in and do something with it. So, the next method is just a way to read that back. Kind of it's the converse of the last one. You're just reading that CSV file and pulling it back into a dictionary. And then we've got our graphing function. So given some data, we've read this block of data from the file. This is really all the code you need to generate a nice, pretty graph. And I wish I would have saved one of the examples so you guys could see it, but it's pretty simple. We're going to make a line graph. We give it our title, and then we loop through our keys. So each key is going to be a line on the graph, because that's the way it'll correspond, and then it will plot the different data points that we've collected. And that's pretty much it. It'll render out to an SVG file. There's another library that does similar, but that's the gist of it. So I'm out of time. Thanks for joining. Really appreciate it. I'll stick around for questions.